Hello guys and dolls, welcome back to Honey Badger 3D Print and Paint. Today we're at Photocentric, taking a look at how they're revolutionising mass manufacturing. But before we get started, roll those credits. So I am here with Paul, the CEO of Photocentric, and we are talking a little bit about what it is that you guys do at mass manufacturing levels. So talk to me about how you're changing the industry.
The most amazing invention that has hit 3D printing within the last 10 years is the LCD screen. It's truly changing everything on a smaller level, enabling people to go and make the highest resolution parts ever. And there are millions of these printers out there. But what we should be asking is, what is it doing industrially? What we're seeing is a piece of technology being used by people who've picked up on it, and actually the large companies are lagging in its adoption. And the reason is that the use of an LCD printer still hasn't matched the more sophisticated, much higher priced models. But they could never offer you the scale or the cost that's needed to make in the millions. To do that, you need to be able to make resins at reasonable prices that are functional. We can do that. But then you need a digital encoding system that's reliable, repeatable, and can do it in mass scale. And that is the LCD screen. So here we are standing in the middle of the Magna print farm. But we have even bigger printers, and then we have arrays of smaller printers. And what it gives us is the ability to make not tens or hundreds, but tens of thousands and hundreds of thousands of parts per day. This changes the cost paradigm. What it does is allow you to think digitally in almost the same way that you would think conventionally with injection molding. And as we see it, the two technologies perfectly dovetail. You can go to market much quicker with much better product. You potentially can just stay permanently on an injection, on an additively manufactured product, rather than go to molding at all. Or you can go to molding when the design is right. And you can go with a better design, and you can go to market earlier to get a greater market adoption of a product. So it really does change the way that companies think. If you sweep all that aside and you just say, but on another level, what does it do? This has much lower carbon footprint. It's at least one order of magnitude lower carbon footprint than an injection molded process. In fact, the LCD screen is the lowest carbon footprint mechanism of 3D printing. So it's definitely the future as soon as the manufacture of plastic becomes a carbon issue and the carbon content becomes something that becomes a tax. Maybe it becomes embedded in a blockchain that's embedded in those barbs, then this is the mechanism that will be dominant. But also it insulates you, of course, as with all AM processes, against the issues of getting tooling in from Asia and parts and getting large demand of stock holdings which you can't meet because of prices, because of war, or because of disruption to the Suez Canal or any other type of major issue at the moment. So what you'll see is companies wanting to have insulation from risk. They'll want to go and give themselves a lower carbon option, but also they'll want to go and change their business model to provide work in progress, was used work in progress, shorter lead times and better products.
So you guys are also, I think what's really unique about it is that you're not just the entire production ecosystem, but you're almost the entire logistics ecosystem as well. There's no scenario in which you make the resin, you have the printers, you make the printers. So whereas a normal production facility has to get things in to put things out, the reality is you guys are making everything in-house. You're doing your own chemical engineering, you're doing your own material science, you're doing your own R&D, you're building your own machines to then be able to do your end-to-end manufacturing as well. And then you also own the entire production cycle because you guys are helping to design the parts, helping to engineer how they would go into the slicer, and then providing that service directly out to clients as well. So that entire ecosystem is something that right now at this level and at this scale, there's really almost nobody in the market who is even beginning to come close to what you're providing. Everybody else is about the democratization of the production chain. It is either self-empowerment with small machines, with small build volumes, with small formats, but they are also, then everybody else is relying on everything else. It is relying on materials to come in to be able to produce the resin, and when their parts break, they have to be able to do those. But you guys are owning the entire piece of that. You know, it's not just, I mean, even Apple farms out who makes their iPhones. You guys are building these about 15 feet away from where we are now. So that entire ownership means that when it comes to things like carbon footprint, clients have a complete bird's eye view of near enough the entire process until you hand it over to sort of a logistics firm to send it out to the client. Yeah. And it's that end-to-end ecosystem that makes you guys just really unique in that space.
That's right. I have to say, and you're absolutely right, and it's an intelligent point, but there would be no other way of doing it. You see, if we were to go and outsource any element of this, significant element of it, we couldn't achieve it. The biggest issue, if you want to make an awful lot of items, is you have to convince someone to buy a lot of items, and the biggest question they're going to ask as soon as they hear additive manufacture or 3D printing is cost. They're going to say it doesn't apply. It only applies to one-off. It applies to very expensive industries like aviation or medical, but it doesn't apply to us. The vast majority of the world does not apply, but now it does. But to do it, you have to be in control of the costs and also optimize them for one perfect product. So what we see is that the entire chain, from the design for additive, which is a very critical part of the whole process, the software design, the engineering of the chemistry, and going back further, the construction of the oligomer, the backbone of this chemistry behind it, done specifically for that application, the machine, the configuration of the machine, the settings, how fast it's going to run, what resolution it's going to run. In other words, what type of screen we're going to be using in this format, what resolution, what intensity of light, etc. we're going to be using. Then what settings, how the clever bit that's a bit hidden, this technical aspect of how do you actually print well. When you put all of those together, then you can achieve scale. You put one of those little pieces out, it's like a bridge, you can't cross the river. That's the problem.
Yeah.
So if we did outsource and say, it's okay, we'll go to a large chemical company and we'll pay 3-figure sums for resin, we're dead on arrival. And this is actually why a large number of the people who are talking about mass manufacture today, they may be a printer manufacturer, they may be a chemical manufacturer, even be a software company or a bureau. They can't really deliver on it because they're not in control of all those elements.
Yeah. And I think there's as well, there's the final part, which is around cost. Control is something that I think a lot of companies like to pretend that they have over costs and over manufacturing and everything else. But when you start to outsource those parts, it's death by 1,000 bee stings. It's that every single person in that chain, every set of hands, puts up their price by 10%, puts up everything else. And you guys during COVID were in a very, very short space of time able to scale, manufacture and supply the material to print thousands and thousands of COVID face shields, which you were then able to supply to sort of frontline workers and to support workers. And that speed at times can be the absolute difference between your product skyrocketing and taking off and eventual production failure because you're choked by those stalls in the logistics chain. One person drops the ball and all of a sudden you have a lot of complications. But you guys are able to create that control because you own the whole so much of that end-to-end process.
Yeah. You go back to 2020 when COVID started. AM was the only thing that could help. People started with the FDM printed versions and they worked successfully. But the scale was impossible.
Yeah.
There were slack groups trying to go and pick up pieces from people's houses, 10 here, 1 here. This isn't the answer to a pandemic, and it quite obviously wasn't. But what it showed us, when we were printing a vast quantity, we were printing 1 million a month, it was 50,000 a day, it was a ton of resin a day, and we were doing it reliably and repeatedly, is we saw the huge problems attached to a manual LCD or any manual 3D process, and that is the human involved in post-processing primarily, much more than printing. And the vagaries of working 24 hours a day and finding errors in the night shift and these sort of things. So it was a huge learning exercise of success and failure. The failure was that that system, the current system, is not actually suited to go mass manufacture. You have to change the system. The system involves autonomous production. You have to strip a person out of it. And people are talking a lot about that, about how do you do it, and you'll see companies showing 6-axis robots picking up napalms and dunking them into wash tanks and dunking them into post-exposure units. And this just really quite obviously isn't the answer. All they're doing is just taking a very expensive robot and replacing a very cheap human with it to do the same process. And probably when something goes wrong, the robot won't know that there's resin all over the thing when it's going into the... So it just doesn't work. You have to re-engineer the process. And that's all we've done. Well, when you re-engineer the process, you actually re-engineer it with an LCD at the heart. In fact, not just one, but hundreds of them. And that is the answer, ultimately, to mass manufacture.
Thank you very much for joining us, Paul. Thanks for the time. Thanks for showing us around your amazing facility. Thanks for watching, guys, and we'll catch you on the next video.